Welcome back everyone. In today's video we are going to solve this problem 2, which is from EGMO 2021. It's problem 2 as I said, and it's of course functional equation. I solved it just like 10 minutes ago in like 45 minutes, I think so, and we are going to solve this here. So to begin, let's call f0 d and f1 c. So right, yes, okay. Now we plug this in and we get f y plus c is equal to f y plus 1. And now if we let y equal to 0, we get fc is equal to d plus 1, yes, and let y equal to minus c, which implies that f0, which is d, is equal to f minus c plus 1. And we will use these two in the future. Now let's use this input, and we get fx plus c times fx plus 1, because we know that fy plus c is equal to fy plus 1, and add y to this and we get fy plus x squared plus 2xc plus c squared. Okay, and this is same as xfx plus cfx plus x and plus s plus c, but we can bring c out like this, and we can add 1 to the right hand side, so we get this is equal to fy plus x squared plus 2xc plus c squared minus 1. And now let's do this, and if we look closely we see that in the original equation we have xfx plus y, and here we have xfx plus this. So left hand side is equal to f this stuff, so the whole thing, I'll just copy this, f this plus x squared. Okay, and we know that this is equal to fy plus x squared plus 2xc plus c squared minus 1. And we have x squared on the both sides, here and here, so this means that cfx plus x plus y is equal to fy plus 2xc plus c squared minus 1. Okay, so let's underline this. And now in the original equation, so here we will put c and 0, and this implies that f cfc is equal to c squared plus d. And if we put right here, actually in this equation, if we put so let's call this actually q, so q x y implies, okay, okay, so we have this, and if we put x and minus x, we get f, this is cfc is equal to f minus c plus 2c squared minus c squared minus 1. Okay, yep, and we know that this is equal to c squared plus d equals to c squared plus d. And actually here we have c squared plus, yeah, 2c squared plus c squared plus c squared, and this equation is same as, also we know that d is equal to f minus c plus 1, so this is equal to c squared plus f minus c plus 1. So we are left with 3c squared is equal to c squared plus 2, which implies that c is equal to plus 1 or minus 1. So let's say that if let's assume that c is 1, okay, just for now let's assume that c is 1. Now this implies that f0 is 0, f1 is 1, and f minus 1 is equal to minus 1. Okay, and now we will do so we will put this actually since we have this already, we know that c is equal to 1, so this means that fy plus 1 is equal to fy plus 1, and this implies that fn is equal to n. Oh, implies, so using induction, if we know that f n minus 1 is equal to n minus 1, then we can put y equal to n minus 1, and this is n, this will become n, so fn is equal to n. And for every integer can be negative also, we have this fn equal to n. Now let's put this into original equation, and we get fx plus n squared, oh no, x plus n times fx plus n plus y is equal to fy plus x squared plus 2xn plus n squared. This is same as xfx plus fxn n plus xn and plus n squared, but we can bring n squared out and this 2 will disappear, so this is equal to f, sorry I missed the y, f1 plus x squared plus 2xn. And we will do the same thing, so we will call this sum z, and we get that this is equal to x squared plus f this. Okay, and we have fx times n, so let's write n here, nfx plus nx plus y is equal to fy plus 2xn. Now we will stop here and prove that if for example a is equal to 1, then this implies that a should be 0. So there is no integer other than a 0 that fa is equal to 0. So to prove this, we will put a and y, and we get f. We are putting this in original equation, so right here, and we know that this is equal to fy because this term is 0, and fy is equal to fy plus a square, which implies that a square is 0, so a is equal to 0. Okay, since we proved this, now we will let y equal to minus 2, for example, say b, and we let, actually, let's call this r xy. Okay, so we have this, okay. So now if we put this, which is fraction of b on d, and minus 2b. Okay, if we put this, we get f, also b and n are integers, to be exact, so we will use this because we know that we can bring integers out here, we know this, so we get f, okay, this is a lot of writing here. Actually, we are putting this in this. Okay, so I'm sorry. So we get n times f fraction of b n plus nx is b, and plus minus 2b is equal to f minus 2b. Wait, actually, yeah, that's correct. Plus 2xn is equal to 2b. Okay, so we have this, and okay, so it's correct now. If we put this b divided to n and minus 2b, we get this, and the right hand side we know that this is 0 because we know that fn is equal to n, so this is minus 2b and sum is 0, so this is equal to 0. And as we proved that if fa is equal to 0, then a must be 0, so we know that n times f um, plus b minus 2b is equal to 0, and this implies that n times f fraction b n is equal to b. Okay, and this means that um, f fraction, any fraction, is equal to itself, okay, like this. So fine. Okay, and we have fx is equal to x in rational numbers, but this was true if c was 1. If we let c equal to minus 1, then we get simply same, but with minus. So we get fx is equal to minus x. Okay, and this is known as pointwise trap. Pointwise trap. So we have fx equal to x or minus x. And if we check both of these answers works, because this is x squared in both answers, x squared minus y is equal to x squared minus y, and x squared plus y is equal to x squared plus y. And to avoid this trap, we will so if there exists a and b not equal to 0, and if a is equal to b a, and if b is equal to minus b, then we can simply put like this. No, actually actually put b and a. Okay, and this implies that f minus b squared plus a is equal to b squared plus a, and we know that this could be equal to b minus b squared plus a or b squared minus a, so this equals to, actually we can divide this into cases. Case 1 is if minus b squared plus a is equal to b squared plus a, which implies that b is equal to 0, and this is contradiction because we said that a and b is not 0, aren't 0. And case 2 is if b squared minus a is equal to b squared plus a, which implies that a is 0, which is again contradiction. and we are done. So we have answer box f x is equal to x or minus x. Okay, we can, okay, okay. And our final answer is fx is equal to x or fx is equal to minus x. And we can't have both of this at the same time, so we can't have fa equal to a and fb equal to b. Fx is x always, or fx is minus x always. And this finishes our solution. Again, this was EGMO 2021 problem 2. Goodbye everyone, and goodbye Tedo.